exactly when at least. Hey everybody, I guess I thought I had paused when I hadn't. At any rate, we'll look at the conjunction or the and of two statements. We know that the conjunction or the and of two statements is false exactly when at least one of the statements is false. Now we're going to generalize that. The conjunction or and of two or more statements is false exactly when at least one of the statements is false. So if we have the conjunction of 25 statements and one of them is false, the whole thing is false. If we have the conjunction of 25 statements, the only way that that conjunction can be true is if each of the 25 statements is true. It's going to be false otherwise. Did I just say that right? No, I don't think I did. The conjunction is going to be true, yes, when at least one of the statements is false. I said it right. The only way it's going to be true is when all of the statements are true. So maybe I should write that down also. This may actually be the special case that we want to remember. The conjunction of two or more statements is true exactly when all statements are true. So if at least one of the statements is false, the whole thing is false. So let me do this a little bit more correctly than when I started out. We like to have special cases for each kind of compound sentence. So this is the special case. The conjunction of two or more statements is true exactly when all of the statements are true. So if we have the conjunction of 25 statements, the only way that conjunction can be true is if every single one of those statements is true. If we have a conjunction of 25 statements and even one of those statements is false, the whole thing is false. Now, let's do the same kind of generalization with a disjunction. Okay, let's go again. Remember that the disjunction or the or of two statements is false exactly when both of the statements are false. The only way that an or statement can be false is if both of the statements are false. Now let's generalize that. The disjunction or the or of two or more statements is false exactly when all of the statements are false. So if we have the disjunction or the or of 25 statements, and at least one of those statements is true, then the whole thing is true. The only way that we can have the or the disjunction of two or more statements and have that disjunction be false is if every single one of those statements is false. If we have 25 statements and we do the or the disjunction of those statements, the only way that that disjunction or of the 25 statements can be false is if every single one of those statements is false. And as far as the general case, this is what we're going to be looking at. This is the special case for an or a disjunction. The only time that it's false is when every single statement is false. Now, before we move on and apply this to consistent and inconsistent systems, let's just do a truth table for a conjunction of three statements and a truth table for the disjunction or of three statements and just see how it works out. Okay, we're going to do the truth table for the conjunction, that is the and of three statements, three simple statements. And we call our simple statements P, Q, R. We've never done a truth table with three simple statements before. And what we want to do is fill it out in such a way that every possible combination of truth values of P, Q, and R appears exactly once. So let's see. Let's suppose that P is true. Q can be true or Q can be false. And R can be true or R can be false. So what we'll do is we'll take the innermost statement and just alternate true and false like we did before. Except this time there are going to be 8 of these. Now let's see. If T is true and Q is true, then R can be true or R can be false. So if both P and Q are true, there are 2 possibilities for R. Now, suppose that P is true, but Q is false. If P is true, but Q is false, there are 2 possibilities for R. Either R is true or R is false. Now, this exhausts all the cases in which P can be true. If P is true, then Q can be true. And if both P and Q are true, then R can be true or false. If P is true, Q can be false. And if P is true and Q is false, there are 2 possible values for R. So all of the other possibilities address the cases where P is false. So I'll let P be false, and we'll let Q be true. If P is false and Q is true, then either R can be true or R can be false. So when P is false and Q is true, there are 2 cases for R. So this exhausts all the cases for P false and Q true. If P is false and Q is true, either R is true or R is false. So if P is false, then the only remaining case is that Q has to be false also. If P is false and Q is false, R can either be true or R can be false. So if P is false and Q is false, there are two cases, true, false. This exhausts all possible combinations of truth values of P, Q, and R without repetition. So all of these cases are unique. Now let's see, what do we want? We want the truth value for P and Q and R. And from what we were told, the special case here is when all three are true. The only way that this can be true is if all three statements are true. So I'll write that down. Special case, true and true and true equals true. All of these other cases have at least one statement that's false. And so the conjunction of these other statements is false. So this is the only case that I need to know for a conjunction. All statements are true, so their conjunction is true. So here's our special case. We don't even have to think about the others, we just write false. And ole, this is our truth table for the conjunction of three simple statements. Now we do the disjunction or the or of three simple statements. And again, this involves 8 possible combinations of truth values for P, Q, and R. And do you remember how we did it the last time? We do it exactly that same way every time we have a truth table for 3 simple statements. The outermost statement, we have true, 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 4 of these. And then false, 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 4 of these. So we have 4 trues, 4 falses. And then when we go to the middle one, we're going to have true, true, false, false, true, true, false, false. And then the inner one, the inner statement R, we have true, false alternating. True, false, true, false, true, false, true, false. So we now have every combination of truth values of statements P, Q, and R listed exactly once. And we said the special case for a disjunction, the only time that the disjunction of 2 or more statements is false is when they're all false. So let's see, special case. A disjunction or an or is false exactly when all statements are false. So in this table, where does that happen? Right down here. P false, Q false, true false. The whole thing is false. This is our special case. And you know what? I think I'm going to circle this again and just draw an arrow to this special case. The disjunction of three statements is false exactly when all of them are false. For every other possible combination of truth values, this thing is true. So without thinking, and it looks like I wasn't thinking when I made this table because I didn't write P or Q or R, did I? This is the statement whose truth values we seek. The conjunction, no, the disjunction or the or of these three statements. We know when this thing is false. It's only false when each of the three statements is false. Every other time the disjunction or the or is true because every other time at least one of these statements is true. So we just put true, 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 true without thinking. That we know the special case. The disjunction or the or is only false when all three of these things are false. So without really exerting ourselves to think, we know that every other possibility has to be true. And I'm going to circle this column in our truth table. And ta-da, there we have it. We have a system of specifications. Let's look at these. A, whenever the system software is being upgraded, users cannot access the file system. B, if users can access the file system, then they can save new files. And C, if users cannot save new files, then the system software is not being upgraded. We want to determine if this system is consistent. And I think the first thing I'm going to do is take this and rewrite it for what it really is. This says whenever the system software is being upgraded, users cannot access the file system. Now, what is that really saying in terms of what we know about logic and propositions? Isn't that really saying if the system software is being upgraded, then users cannot access the file system? Isn't that really what it's saying? Now, this next thing I think is fairly straightforward. If users can access the file system, then they can save new files. And what about this? If the users cannot save new files, then the system software is not being upgraded. Okay, I think we know what's being said. Now, the next thing that I want to do is express these things in terms of simple statements or simple propositions. The first proposition, the first simple proposition or statement that I see is the system software is being upgraded. So that's going to be my P. The next proposition that I see here is users cannot access the file system. Now I see the word cannot in here, so I'm going to look at this as the negation of a proposition. I'm going to consider the second proposition, Q, to be this. Users can access the file system. So that would really mean that this simple statement is not Q. Q is users can access the file system. So this would be not Q. Now, what do I have down here? Users can access the file system, that's Q. They can save new files. Let's see, do I have that here? I don't. So I guess that's going to be my third simple statement. Users can save new files. Okay, what about this? Does this sentence or this statement have anything new? Users cannot save new files. That's the negation of R. The system software is not being upgraded. That's not P. So there's really nothing new there as far as simple statements go. So I've identified my simple statements or simple propositions as P, Q, and R. Now what I'm going to do is I'm going to diagram these three statements. If the system software is being graded, then users cannot access the file system. Okay. Users cannot access the file system. That's the negation of Q or not Q. Yikes, can you see that? Maybe with binoculars. Okay, not Q. The system software is being upgraded. That's P. So we have if P, then Q. So here's my then. Okay, let's look at this one. It's another if then. Users can access the file system, that's Q. And they can save new files, that's R. So I have if Q, then R. And let's look at the last one. The users cannot save new files. That's not R. The system software is not being upgraded. That's not P. And this is another if then. If the users cannot save new files, then the system software is not being upgraded. So I'll put this arrow here. It's not R. It's if not R, then not P. So essentially, those are our, what would we call them? Our system specifications. A, B, and C are our system specifications. So here's what we're going to do. We're going to determine if they are consistent. A, B, and C will be consistent if the conjunction of those three things is true at least for some combination of P, Q, and R. And I think I'm going to write down what A, B, and C are symbolically. A is P implies not Q. B is Q implies R. And C, that is not R, implies not P. And I think in class I said that I would be a really nice guy and put parentheses just to avoid ambiguity. So I'm going to do that here. I'm going to set the example. My conscience prodded me to do that. So we want to determine whether this system of specifications, A, B, and C, are consistent. Okay, we're determining if our system of specifications is consistent, and it will be consistent if A, B, and C, the conjunction of those three things, is true for at least one truth value combination of P, Q, and R. We have three simple statements, which means there are 8 possible combinations of truth values. So how do we fill this truth table out? Since we have 8 combinations, on the very outside we do 4 truths, 4 falses. In the middle we do true, true, false, false. And then all over again we do true, true, false, false. And on the inside we alternate true and false. Now let's see, what else do we need? In order to do this statement and this statement, we need the negation of P, Q, and R, so let's do that. Not P, not Q, not R. And for not P, we just change the truth values of P from true to false. And from false to true. For not Q, we change the truth values of Q from true to false. And from false to true. And from true to false. And from false to true. And for not R, the same thing. We change true to false and false to true. So alternately we'll go false, true, false, true, false, true, false, true. Now, what the heck? Let's just do A, B, and C. A, That's P implies not Q. And this is an if-then. The only time that this is false, let's see, what's the special case for an if-then? We have to have a what? A true implying a false, and that's false. So we look for the case where P is true and not Q is false. So here we go. P is true, not Q is false. It happens here, the first two rows. So we have false, false. All of the other times this thing is true. By the way, maybe you're starting to notice that if we don't have our special cases memorized, we are up that creek of proverb and legend without a paddle. So we got A. Let's do B. Q implies R. So I'll mark this as B. Q implies R. And this is another if-then. This is false exactly when we have true implying a false. So when we have Q true and R false, this thing is false. So where does that happen? Right here. Q is true, R is false. Q is true, R is false. Right here, Q is true, R is false. Every other place it's going to be true. And then we do C, and I think I'm going to have to give our friend C a little bit more room on this truth table. C, this is not R implies not P. Oh yeah, I had to give that a lot more room. This is an if-then. The special case is when we have true implying false. That is when we have not R true and not P false. Does that happen? Let's see. Not R true, not P false. Here it happens, right here. So this is false. Where else? Not R true, not P false. Right here. And it can't happen, wait a minute now, let's see. So we want not R true and not P false. So we have not R true, but P is true. We have not R true, but P is true. Okay. The only two places where we have not R true and not P false are here and here. We've accounted for those. All other cases, this statement is true. And now we want the conjunction of our system specifications, A, B, and C. So what we want really is A and B and C. It's a conjunction. What's the special case in general for a conjunction? It's only true when all three are true. So let's see. A is false here and here, can't be true. A is true here and here. And here, A, B, and C are true, so we have a true here. And here, A, B, and C are true. Okay. And here, A, B, and C are true. And here, A, B, and C are true. Now let me just take a look and make sure I did it right. The other way I could reason on this is if there's at least one false, the whole thing's false. So this is going to be false. 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 Yep, it works out perfect. The special case told us we have true, 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 true. And all of the other cases, like here, we have A false. Here, we have all three false. Here, we have C false. Here, we have B false. So all of these are correctly false. These are the truth values for the conjunction of A, B, and C, our system specifications. So here's what I conclude. The conjunction of A, B, and C, our system specifications, is true for at least one set of truth values of P, Q, and R. For example, it's true here. When P is true, Q is false, and R is true. The conjunction is also true here. When P is false, Q is true, and R is true. And it's true here and here. When P, Q, and R are false, false, true, and P, Q, and R are false, false, false. The conjunction of these three system specifications is true for at least one combination of truth values, P, Q, and R, the simple statements that make up the system specifications. So this system is consistent.